All right, well, we'll get rolling. Good morning, everyone. Thank you for joining us for another installment of the Long Coffee Break. My name is Billy Donovan. I'm a sales engineer based out of Long's Littleton office. Today, we're going to be talking about a topic that's pretty close to my heart, containment housings. And we're joined by George Santillian from AAF, and he's going to give us a little overview. George, I'll let you take it away.
Thank you, Billy, for the introduction. I appreciate it. And thanks, everybody, for allowing me to be on your break with you. So let's get into containment. So we're going to go through introducing the containment system, market applications, where these are found, the BIBO section layout, how it lays out, the type of containment housings, and the common containment housing questions. So what is this BIBO, this bag in, bag out system? It is a containment system that is utilized in applications and environments that have hazardous or toxic constituents that have to be removed from the air in just flatly utilizing some type of HEPA or ULPA HEPA filter. We build these to the standards that are listed in below. The mechanics of a bag in, bag out system is, it's a positively pressurized locking mechanism that a bag will go over an open door in the bag in, bag out containment system. So you can either test the system or remove those filters and products out of it in a very safe and risk mitigated situation. And then the importance of the bag in, bag out is what I was just alluding to: operator safety, protecting the operators or anybody that is utilizing the system from exposure to these hazardous and toxic constituents. Containment control: you want to make sure that the environment that you're in is not contaminated, and therefore contaminating or risking issues with the products or the people in those environments. And then, of course, regulatory compliance. We have to meet regulatory compliances for, again, safety reasons. The applications that you'll find these containments in you'll find them in all biosafety applications, and then nuclear. They're found in nuclear, found in chemical, government, military, home security, in space, universities, labs, life science, every pharma and medical device application that you can think of. And now new EV battery and like cathode in the cathode manufacturing parts of the of EV battery, which that's kind of a new one. And of course, in many, many others. And then when you look at a typical layout for a containment system, a BIBO containment system, where you're going to start with are the bubble type dampeners, which you'll find on both sides, or not both sides. You can find them on both sides of the containment, and these are apparatus that control the airflow of the system, but also are for shutting off the system for if there's an issue and if there's a risk. This will actually shut the air off from the system so you can manage the system safely. Then you have a pre-filter section, which is usually an ASHRAE product that protects the downstream HEPAs and ULPAs and other filters that might be a part of the system, and also the integrity of the entire system. It protects it from the larger particulate, the 10 to 0.3 micron particles that are in the system, that are in the air. And then you have an upstream testing section, which is where you would introduce your agent for testing, and that's where you would introduce it there, so then you can test the filters for leaking or the overall integrity test. And then you have the HEPA section itself. The reason for the system is to take out all of those hazardous and toxic constituents, and that's what the HEPA filter is for. Then behind that, you would have pressure sensors with gauges and guards. So that's section 5, and that will show you the static pressure of the system. So from initial throughout, and this gives you an idea of when you should be changing your filters. When it gets to a certain level, you would change out the filters. And then downstream scan system. Well, you have a downstream scan system to scan that agent that was introduced in the test ports above upstream. And this is for your validation and overall integrity testing and leak testing. That's part of it. And then you might have another HEPA section, and then that would then constitute another downstream section. And then you would have decon ports, which are utilized to make sure that when you do have to service the unit or test the unit, that it's decontaminated and that nobody's exposed to anything or any of the constituents that might have been in there. Now, a lot of people understand that there are many different types of containment systems, bag in, bag outs. So I have a few here for you to view. So you have a standard side in, side access HEPA housing on the left. This is the one that you will see most in most applications out there. It is pressure tested to 10 inches, of course, manufactured to the proper standards. And again, this is the most popular that you would see out in the field in most segments. And then you have a low law return, RSSAV. And this is utilized for is air balancing in life science and clean room applications, and when there's air mixing. And you typically will find it on the wall, starting low on the wall, and it looks like a refrigerator, it could be a small or a big looking refrigerator, and that's what you would see in those types of applications, and in biosafety too. And then finally, you have our AstroSafe G, which is a ventilation BEBO, which is integrated directly into the ductwork, and it is utilized in low airflow situations where it's really low airflow. And you do see these in nuclear applications and in life science applications and biosafety applications. Now, containment housing design common questions.
Oh, thanks for that, George. I took the liberty of putting together a few questions that I've commonly received when discussing containment housings. And I know you went over a lot in that system overview. And maybe this will help clarify some things for the audience. You ended with decon ports. Are decon ports always necessary for containment housings?
No, Billy, no, they're not always necessary for containment. In biosafety, they are always mandatory in biosafety, and in many life science segments, you'll have that they're necessary, but they are not necessarily necessary in every application. Though I would tell you that I think that they should be something that's added to most, if not all, containments, because of the value that they add for risk mitigation and making sure that efficiency of the decon is done properly. And that's what I would say. But no, it's not necessary. It's not something that has to be a part of a system.
All right. Another one I always I hear a lot of is pre-filters. I mean, what are your thoughts? Do you think would you recommend them in every application? Do you think they're necessary? Do you think they're an added cost?
Okay, so great question, because there's a lot of different thoughts on this. No, you don't have to have them in every single application. Do I think that they're a benefit to the system, the overall health of the system, and then the overall life of your HEPA filter or ULPA filter downstream? Yes. So if you're in a situation where the environment is pretty dirty, you probably want to have one, because it'll help that with the overall health of the containment system, and also save you a lot of money with those expensive HEPA and ULPA filters downstream for their life. They'll last longer. But if you are in a situation where you have pretty clean air coming in, you have a system, a robust system with MER 14, 15, 16 upstream, now you wouldn't need them.
Awesome. You know, typically when we're talking, when we're going through containment housing design, a lot of people have a tendency to over-engineer it and add in a lot of features because, you know, it is for safety. But I mean, what are your thoughts on in-place test sections? You know, I see a lot of people requesting them. Are they always necessary?
No, they're not always necessary. Where they are necessary are in your like your biosafety, your BSLs, and in many life science, applications. And those are based on the ISO, level of the clean room and the standards there, because of testing and annual and even more often on the integrity validation and leak testing that you have to do. They are necessary and should be part of your system. But outside of that, you really don't need to have one. It would just be based on preference at that point.
All right. And I know what my answers are for this last question, but I'm curious to hear what you have to say. Are there any features or options that you think are essential or should be required for all containment opportunities?
Yeah, I do, Billy. I really do believe that isolation dampers should be part of all, if not all, 95% of all the BEBO containment housings that go out there, because they're risk mitigators. They are something that will help, in a bad situation. These are the things that will stop airflow and will keep that constituents and those hazardous and toxic constituents in the system, or inside the containment, I should say, and really a big risk mitigator. And also, they really do help make it easy for you to adjust airflow much easier. But for the risk mitigation, I really feel that it is essential to have as part of your system.
Awesome. Yeah, I couldn't agree more. I'd also add, I think having factory provided inlet transitions and outlet transitions is a no-brainer as
Yes.
well.
Yep.
Just making sure that the system end to end coming from the factory is going to meet spec and the standards. This photo on this slide is actually something I put in. I took this photo 2 years ago on the roof of a hospital, and started off as a pretty well designed containment housing, and it really got VE'd down to just a box holding a HEPA filter. There's no inlet dampers on it, so when the fan wasn't fully turned down and they open up the door, you can see that the bag inflated. You can see right at the bottom of that elbow, someone decided they'd put in their aerosol injection port, and that's not 10 duct diameters from the filters, so probably not getting proper aerosol dispersion there. So another missed opportunity. In place test sections would have really helped there. And yeah, funny enough, like the outlet transition on this housing, I heard a pinhole leak that night, which is kind of scary. But no, I appreciate your time. Thank you so much for joining us today, George. If anyone has any questions regarding containment housings or filtration in general, just please reach out to your Long representative. Again, thank you everyone for attending this week. Please join us next week when Andrew Schmidt will be presenting on Daikin R32 VRVS systems.